Alright, so we're going to continue our discussion on the integral from Chapter 4, Section 2, and Section 3. Remember from yesterday that we defined the integral as the area under the curve, or the area between the curve and the x-axis. We used Riemann sums to estimate this area. We realized that there was some overestimation or underestimation depending on how the curve was moving and whether there was an overlap or sort of quote-unquote underlap. But we realized that as we made the rectangles smaller, that error became smaller and smaller as well. So to start today, we're going to be dealing with the same function that we were dealing with yesterday, t squared, and we want to find the area or find an estimate for the area under the curve. Again, we're going to do a Riemann sum in 4 parts. So that means each part has a width of 1/2, but this time we're going to do it a little bit differently. Instead of a right or a left Riemann sum, we're going to do what we call a midpoint Riemann sum, where the height is determined by the point that is halfway between the two x values. So in this scenario right here, it's determined by the point in between. So that would mean that for this first rectangle, the point is determined by 0.25. Here, the height is determined by 0.75. Here, 1.25, and here 1.75. I'll give you a moment to copy down the picture of the midpoint Riemann sum. Okay, so the first rectangle has a width of 1/2 and a height of 1/4 cubed, or 1/64. The second rectangle has a width of 1/2 and a height of 3/4 cubed, or 27/64. The third has width of 1/2 times 5/4 cubed, or 125/64, and the fourth rectangle has a width of 1/2 times 343/64. We're not going to waste time today adding those up. I'm sure that everybody can add those up, but that's how you do a midpoint Riemann sum. The fourth and final type of Riemann sum is a trapezoidal Riemann sum. For a trapezoidal Riemann sum, I figure out how many parts. In this case, we're going to do a 3-part Riemann sum, which means each one has a width of 2/3, and I'm connecting the left and the right height to form a trapezoid. For those of you who don't remember the area of a trapezoid is the height times the average of the two bases. So to set this problem up, we just add the 3 areas of these trapezoids. So you kind of have to think about it as, I know we said that it's height times the average of the two bases, but the way that these trapezoids are technically standing on their heights, right? So the heights are 2/3 apiece on every single one. So I just need to find what their bases are. The base here is 0. The base here would be 2/3 cubed, or 8/27. This base right here would be 4/3 cubed, 64/27. And this base here is 8. So I add it up. So I go 2/3 height times the average of the two bases, which for the small one is 0 plus 8/27 over 2, right? Height times the average of the two bases, plus for the second one, the height is 2/3, and the average of the two bases would be 8/27 plus 64/27 over 2. Plus for the final one, the height would be 2/3, and the average of the two bases would be 64/27 plus 8 over 2. We're going to use the same parabola as yesterday to practice. Go ahead and draw the parabola and draw in a 4-part midpoint Riemann sum to estimate the area under this parabola from -3 to 5. I'll give you a few moments to complete that. So there are my rectangles drawn in. The leftmost rectangle has width 2, height 10. Then the second one has width 2, height 2, then width 2, height 2, and width 2, height 10. So I'm going to end up with a total area estimated at 48. Alright, I'll give you another 2 or 3 minutes to attempt a 4-part trapezoidal Riemann sum to estimate the area from -3 to 5. And here is the answer for the 4-part trapezoidal Riemann sum. Sometimes they'll ask me to do a Riemann sum and they won't give me the function, they'll just give me a variety of points on that function. When I see this sort of chart set up, I'm going to draw those points on an XY axis and then draw in the rectangles or trapezoids depending on what it's asking me. This problem is a 5-part Riemann sum, and then they give me the points. So I'm going to go ahead and draw in this point's 2, 14, and then 6, 8, 10, 5, 14, 3, the next point at 18, 7, and the final point at 22, 10. The reason I want to draw those is because it really helps me identify the rectangles. So the first rectangle, we're doing right Riemann sum, so it starts there. The second rectangle, third rectangle, fourth rectangle, and fifth rectangle. And they don't need to be like beautifully drawn, obviously mine aren't, but it just helps me visualize the rectangles. So I know the first rectangle is 4 wide and 8 tall. This is 4 wide and 5 tall, 4 and 3, 4 and 7, 4 and 10. So from there you could pretty easily set up the sum that adds those 5 areas together. For your homework, I want you to do 4.3, 27 through 30, but I only want you to do a trapezoidal sum on those problems. As always, the answers with my work will be on Edmodo, and if you have any questions, feel free to use the comment section. Have a good day.